Okay. So this is a continuation of chapter 4, a review sheet before we move to chapter 5. There are a couple questions on the review sheet, so let me do the first one. The first one has to do with the expected value. A life insurance company sells a $250,000 one-year term life insurance policy to a 20-year-old male for $350,000. According to the National Vital Statistics, the probability that the male survives this year is 0.998734. Compute and interpret the expected value. Okay, when you buy an insurance, you pay $350. Once you pay the $350, guys, this is the money that you lost already. So it's a negative $350. What is the probability that you're going to lose this money, which is a good thing, because if you lose this money, that means you're not just the person survived, did not die. So it's 0.99 as they gave us 8734. Now, what is the probability that the person's family is going to gain, some money after the person, dies? This is when they get the 250,000, but you already paid 350, so it's going to be 250,000, so it will be 49,000, and you have to subtract the 350, will be 650. That's the money that the person's family would gain. What is the probability that the family will get that money? Hopefully, it's a very low probability. Well, it's going to be 1 minus this one. This is the probability of surviving, and the probability of not surviving should be 1 minus this, because they both add up to 1. So it will be 1 minus 0.998734. And let me compute this for you guys. It will be 0.001266. And now I can find the expected value. Watch. It will be negative 350 times 0.99874 plus 249,650 times 0.001266. I already did the math for this one, so I'm going to share the answer with you. It's negative $33.50. So it's a good thing it's a loss, because the person definitely would hope that he or she survives. So on average, the person is going to lose $33.50 for each year of policy. That is what the expected value means. Any questions, guys? Again, the expected value is the mean. Don't forget that. If I ask you to give you a distribution table, ask you to find the expected value or the mean, it is exactly the same thing. One of the questions I asked last semester, something very simple like this. I just gave students the table. And then I ask them to find the expected value. Well, the expected value is the mean. So you take 0 multiplied by 22 over 70 plus 1 times 15 over 70 plus 2 over times 20 over 70 plus 3 times 15 over 70. Sometimes it is faster. If I only ask you to find the mean, it is faster to do it probably by hand and then use a calculator to compute the answer rather than just putting this in L1 and then L2. Unless if I ask for the standard deviation, definitely you want to use the calculator.
I have a question.
Yes.
So say that the person didn't survive. Does that mean that the answer would be positive?
Oh no, it's always negative. It's going to be negative because the insurance hopes that they don't have to pay, and the person himself hopes that he or she doesn't die.
Okay.
So it will always be negative.
Okay.
I wouldn't buy it, just if I knew that this is and actually, you know what? If the expected value is positive, the insurance then will find out that maybe the person has some conditions, terminal condition, and they wouldn't sell them the policy. So it's going to turn out, no matter what you do, this is going to be very, very high. It has to be high in order for the insurance to sell it. And this is going to be very, very low. All right, the next one. This is a mimic of your assignment, guys. So please pay good attention to this one. Question 2. According to the American Lung Association, 90% of adult smokers started smoking before turning 21 years old. Okay, so 90% is P. 10 smokers 21 years old or older are randomly selected, so that's N. And the number of smokers who started smoking before 21 is recording. Explain why this is binomial experiment. Okay, we have fixed number of trials, 10 customers, 10 people. Probability of success does not change. Is 0.9, does not change from one person to another. The possible value of X for people who started smoking before they became 21 years old could be as low as 0 all the way, guys, to 10. So any questions I ask you, they have to be in the vicinity of 0 to 10. It can't exceed this. It could be as low as 0 or as high as 10. So let's begin with the first question. Use your TI-84 to find the probability that exactly 8 of them. So remember, guys, what I said yesterday about exactly, you use binomial PDF. So exactly 8, you write it like that. Probability of X equals 8 equals. I'll write it down and then I'll demonstrate the calculator. Binom PDF, and then you put N, you put P. These don't change, always fixed. The only thing that changes X, which is the last value here. So that's going to be 10, 0.9, and then 8. And here's how you do it on your calculator, guys. That's from yesterday's. So it's going to be second, distribute. I'll send you a handout. I'll include under instructor notes a handout for calculator use, the binomial PDF and CDF today. So check it out. The videos from yesterday should be there. So N is 10, comma, 0.9, comma, and then X, he says 8. It's 0.1937. C, use your TI-84 to find the probability that at most 8. Again, yesterday I told you guys about at most. This is binom CDF. So at most is binom CDF, straightforward. Started smoking before 21 years, becoming 21 years. So it will be probability of X. At most, guys, means less than or equal 8 equals. Let me write it down and then I'll demonstrate that. At most 8 means 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1 or 0. So what the calculator is going to do in CDF, it's going to do a PDF at 0, at 1, at 2, at 3, at 4, at 5, at 6, at 7, 8, and add them all up. You don't want to do all of this, so you just use binomial CDF. It will be 10, 0.90, and 8. And remember, guys, these are not the same. This is a P and this is a C, totally different formulas. Okay, let's do this. Here's the calculator. Second, distribute. Binomial CDF. Okay, N is 10, comma, P is 0.90, comma, and then 8. That'll be a large answer. 2639. Next question. Use your TI-84 to find the probability that at least 5 of them started smoking before 21. At least, guys, means greater than or equal to. This is probably, we haven't done that at least. We didn't do that at least yesterday. X greater than 5. Okay, let me explain how to do this using the calculator. You could do this by hand. At least 5 means 5 or 6 or 7 or 8 or 9 or 10. So you can run a PDF on each one of them and then add them up. But I'm going to show you a shortcut. At least 5, we said it's 5 or 6 or 7 or 8 or 9 or 10. Do you guys agree that this is what at least 5 means? Okay. So let me show you the nice shortcut you can use with the calculator to figure this out. The calculator can do at most only what is left for from 0 to 10. We have 4, 3, 2, 1, and 0. And would you guys agree with me that this means at most 4? Well, the calculator can do that. So if we can do the 0, 1, 2, 3, 4, so the calculator can do from the number backward, we can subtract this answer from 1 to get what we want. All right, so at most 4 is a binomial CDF on 4. So our answer is going to be 1 minus binom CDF 10, 0.9, and then 4. And again, how did I figure out that I have to do 4 and less? Because these are the values that he didn't ask us about, but I can use the calculator to do at most 4. I cannot do at least with the calculator, and then subtract the answer from 1. So this is going to be 1 minus, guys, and let me run this one.
Can you put up the paper just a little bit?
Right, there you go. What about the audio now, Diva? Is it working? Is the audio working okay for you guys?
Mine's working.
Okay.
Mine is working as well.
Yeah.
Yeah, okay. Just let me know. I mean, I like technology, but you don't know what the other side is hearing or seeing. And it has to do with the internet connection, the bandwidth. Okay, great, thank you. So let's do this. And this is very much it after we do the other two parts. So binom, if you want to see, guys, how I can recall this function without even going back, you know, just to variables and find it, you can press second and enter. Watch, second, enter, and then you can edit. So I'm going to just change the 8 to 4. So that's, and I got, it's very small. Don't ignore the E negative 4. The E negative 4 means you have to move the decimal point 4 digits to the left. So this is going to be, guys, 0.0001. And I guess I know what the answer is going to be here. That's the answer. All right. Now, next question. Let's move to the next question. Use your TI-84 to find the probability that more than 5 of them started smoking. Okay, can you tell me, guys, how do I start with more than 5? What's the first number?
6.
And then 7, and then 8, and then 9, and then 10. Okay, guys, I cannot go from a number upward. The calculator doesn't do it. It only does from a number downward. Okay, this is what we want. But what we didn't want is the 5, the 4, the 3, the 2, the 1, the 0. So can you see, guys, what I'm going to do now? I'm going to do probability of X greater than 5. It's going to be 1 minus what I didn't want. How do I express what I didn't want? using CDF. It will be, can you guys help me? Binom, CDF, 10, 0.9, and what goes here? Can someone say it? We're gonna do this. And then subtract the answer from 1. You agree, guys? It's 5. So there will be 1 minus, it's not the same here, it's 4. Let's do it. Second and enter. I get it back. And change this to 5. 0.016. And then the answer will be 9984. Find the mean and the standard deviation. That's an easy part because it's a formula I just used to do it. The mean, guys, I always provide you with those formulas when you are asked this question. So the mean is n times p, 10 times 0.9, which is 9, done. Standard deviation is square root of n pq. Okay, let's do the math here. N is 10, p is 0.9, and q is the complement of p. If p is 90%, q is 10%, because they should add up to 1. And there will be square root of 0.9. And let's figure this out on the calculator. 0.9 square root. Don't forget to do the square root. Many times the students forget to do that. So it's a 0.95 if you round to 2 decimal places, as you can see. Okay, I'm gonna add one more question, guys, so then I will have covered every thing. G. Find the probability that less than 4 started smoking before 21, before becoming 21 years old. Okay, less than 4, we write it like this, guys. Okay, can you help me list the numbers that are less than 4? What's the first number?
3,
3, 2, 1, 0. Okay, so this is gonna be binom CDF. 10 doesn't change, 0.9 doesn't change. Okay, do you guys agree with me that less than 4 means at most 3? We need the at most word in order to use the binomial CDF. So it is at most 3. You put 3. If a student put 4 here, they will be wrong because you included the 4. Less than 4 doesn't include the 4. It's a 3 or less. And remember, there are no decimals here because we're doing discrete variables, whole numbers. We cannot break them down into pieces. And then you can do the math and find this one. For the assignment, guys, let me go over it with you. Just make sure we understand it. So my idea for the assignments, guys, so that will be a learning experience for you and prepare you for the tests. So this is a P here, 43%. Don't leave it as 43, write it as 0.43. According to the 2015 American Community College, okay, we're enrolling in college. 15 women were randomly selected. So this is your N. Find the probability that exactly 7 of them, you should know that. So exactly, that's gonna be what? A binom what? PDF. At most, just like in the previous exercise, This is what the binom what? CDF. Find the probability that less than 10. Can you tell me verbally what do you do here, less than 10? What does it mean? How would you do this one? Less than 10 means at most what?
9.
At most 9. And then you run binom CDF on 9. Find the probability that more than 6. More than 6, you write it like this. So that means 7, 8, 9, 10, 11, 12, 13, 14, and then 15. So in this case, we cannot do from the number onward. We do it from a number backwards. So you guys, you run binom CDF on at most 6 and then subtract the answer from 1. And for the last part, guys, compute the mean and the standard deviation. Mean is NP and sigma is square root of NPQ. What I'm gonna do here, yes, any
Would
questions?
this one, yeah, would this one be for D? The last one would be at least 7 or at least 6.
Oh, I didn't do at least. There is no at least in this one.
Okay.
So there is no match with the ABCDs. There is a match with the questions, but not A doesn't match with A over there and B doesn't match with B. Just pay attention to that. Okay, here's my summary, guys. And I will, you can write the notes. I'm gonna give you a summary of how to use the calculator for any situation. So you will be given always N and P and X for sure, definitely. If you are asked to find a probability of X is exactly A, here's how you do it. Binom, PDF, N, P, and then you put A, and you're done. There you go. You don't see what I'm writing. Now you can see it. Now, if you are asked to do probability of X at most A, also it's a straightforward, guys. It's binom, CDF, N, P, A. If you are asked to find probability of X less than A, you do binom, CDF, N, P. Any guesses, guys? What should go here? Like X less than 7, it's X at most 6. X less than 14, that means X is at most 13. So what do I do that to make it a formula that works?
1 minus A.
A minus 1. Good job. 1 minus A doesn't cut it. We'll give you a negative number. Oh, I counted to 15 because somebody is asking me why I counted to 15 to D, because N is 15. And more than 6, you have to go for more than 6 up to 15. More than 6, you start with 7 all the way to 15, because N is 15 in this exercise. Now, guys, the 2 more scenarios, and you can use this to answer any question. X greater than A. It will be 1 minus binom CDF. Greater than A, let's say greater than 6. Greater than 6 means 7, 8, 9, etc. So that will be 1 minus binom CDF, N, P, and then A. So if I ask you to do probability of X greater than 6, you do 1 minus binom CDF. You put the N value, the P value, these fixed, don't change, and A is 6. And the last one, guys, the at least. At least is written like that. It's 1 minus binom CDF and PA minus 1. Okay, this equal means exactly. This means at most. That's a little bit of algebra. This means less than. This sign, more than. I mean, the book might say greater than. I cannot guarantee it's going to be the same wording, guys. But most of the time they say what we put here, and this is at least. Now, one thing, guys, you might come across, I'm not sure if I put any problems. Let's say if I ask you to find probability of X between 2 and 4. Does anyone know how to do this? Using PDF. What does it mean for X to be between 2 and 4, greater than or equal to 2, less than or equal to 4? It means X could be 2, could be 3, or could be what, 4. So you run a PDF on 2, PDF on 3, PDF on 4, and add them up. So it will be probability of X equals 2 plus probability of X equals 3 plus probability of X equals 4. And the last thing I want to review, guys, for the binomial distribution, the mean is NP, and sigma is square root of NPQ. And for the probability distribution, remember that the mean is the expected value. It is sum of X, Px. And the rules for the probability distribution are, it has to be between 0 and 1, all probabilities, and the sum of all probabilities must equal to 1. This is pretty much it for chapter 4. I will send you direction, guys, and how to submit this assignment. Shouldn't take you, once you finish, that chapter, it should take you 10 minutes to get it done. All right. So I'm gonna stop sharing now, and I'm gonna share a new document with you. You should have received this one by email. And let me just project it so you can see what I'm talking about. Here we go. Let's focus. All right. This is, guys, chapter 5. It is normal distributions. And from now on, guys, till we're done, it's all about normal. It's going to be all normal distribution. You did chapter 4, it's discrete variables, 0, 1, 2, 3, but we're no longer interested, in discrete variables. We are interested in continuous variables. Continuous variables are measurements, are values that are measured, and they're not discrete. For example, your weight, your height, your age, temperature outside, these are all continuous. Again, discrete, guys, you can count it using your fingers as 0, 1, 2, 3. There is no a half, there is no a quarter, there is no 0.37. It's all whole numbers. But in the continuous case, it's everything else. So it has an infinite number of possible values that can be represented by an interval on the number line. Like hours spent studying in a day. This is not discrete, guys, because you could spend 12.1 hours, 12.3 hours, 5.5 hours. If you can represent, your value using a decimal, then guys, it's not a discrete, and that is what we are interested in. A normal distribution, guys, looks like this. It's going to be a bell-shaped distribution, just like a symmetric bell-shaped histogram. This is what we will be working with until we are done with the semester. So focus well on the chapter 5. The kinds of distribution you see, you're going to see it every time I meet with you. So we're going to be working with this from now on. Okay, so we know what a continuous variable is. Again, forget about discrete variables. the most important continuous distribution in statistics is the normal distribution, which is the bell-shaped. Okay, the graph of a normal distribution is called, can someone tell me what the word here? I've said it already.
Bell-shaped?
Bell-shaped curve. That's why where I want you guys to take notes with me. If you printed this out, if you didn't, do it later and then work with me on the rest of the handout. Properties of the normal distribution. What do you think, guys? The mean, median, and mode are what? They're here.
Are they equal?
Yes. Good job. This is why I want your participation, guys. If you don't participate with me, I can finish in half an hour, you know, and but it wouldn't be good. The normal curve is bell-shaped and symmetric about the mean. So the normal curve, half of it is reflected, you know, just from the center, you know, just to the other side. That's what the bell shape look like. The total area under the curve is equal to what?
100?
100%. Always, guys, sum of probabilities must equal to 1. Any probability distribution, the total distribution should give you a probability equals to 1. Otherwise, it will not make sense. For example, guys, if I want to talk about distribution of rain, either rain or no rain, if the probability of rain is 70% and the probability of no rain is 30%, well, if you add 70% and 30%, you should get 100%. Okay, let me do this and then maybe you can help me figure out the last part. Watch. This curve should not have touched here. It should be go along with the axis but never touches. But there is no technology that can graph it, you know, just this way. So what I wanted to say here, the normal curve approaches but never what? Touches. Yes, but never touches the x-axis, that it extends further and further away from the mean. Let's show you some examples of the normal distribution. Again, guys, remember, once you're done with 4, focus on the continuous normal distribution. That's going to be the distribution from now on till the end of the semester. A normal distribution can have any mean and any positive standard deviation. The mean gives the location of the line of symmetry, the middle, and the standard deviation tell you how flat the curve is. Okay, can you guys see the mean here? It's right here, which is between 3 and 4, 3.5, and the standard deviation is 1.5. Without me showing you the second curve, guys, I think it's going to have the same mean, but do you think it's going to have a larger standard deviation or smaller standard deviation?
Smaller.
Smaller, because it's not as widespread as the previous one. I agree. The flatter the curve, the larger the standard. And look, guys, it's 0.7. Now look at this curve. It has the same opening at this one, so they should have the same standard deviation, but this curve is a little bit toward the left, so it might have smaller mean. And look, the mean is 1.5. In this example, we're trying to show you guys that 2 distributions can have the same mean but different standard deviation, or 2 distributions can have the same standard deviation but different means. So it could be either this or that. Any questions here? I wouldn't give you a curve and ask you guys to determine the standard deviation. That's not easy. All the data has been plugged in into calculator to find this standard deviation. So we usually provide you with those informations. But I might give you guys 3 curves. The opening of the curve is different in all 3 scenarios, and ask which one has the largest standard deviation, which one has the smallest standard deviation, which you already done that on the test, but with histograms. The bell-shaped curve, guys, think of it as histograms, but very thin bars. So something like that. This is how I like it to think of the bell-shaped curve. Watch. Think of them as histograms, but with very, very thin bars. You make them thin, 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 thin like that, and then you get the bell shape just like that. So that is what a bell-shaped curve or continuous curve is. And the reason why you have to make a bell-shaped curve, because in the discrete case, you can jump from 0 to 1 to 2. In the continuous case, they are all connected, you know, from 0 all the way to end. And that's why we have to connect the bars like that. Next, let's do the second page. All right, an exercise for you guys. That's an easy one. Which curve has a greater mean, A or B?
A.
Do you guys agree? Does everyone agree that it is A because it's more toward the right? And I can tell you the mean is 15 for A and for B is 12. So A has mean of 15. B has mean of 12. So the answer is A. Which one has a greater standard deviation? Do you guys agree it is B because it's wide, more wide open, more spread out data? So B has greater. You don't need to know what the standard deviation is. You can just by looking at the curve tell. Although this chapter is important, it doesn't mean it is hard, guys. You will see. You might like it even more than chapter 4. Because in chapter 4, you work with at most, at least, etc. There is no such a thing, you know, in the continuous case. Standard normal curve. So we define the normal curve. It has a mean and a standard deviation. Now, a standard normal curve is when you change the values to z-scores. So a standard normal curve is with the mean of 0 and a standard deviation of 1. This is called the standard normal curve. So when you change the regular curve to a standard normal curve by counting standard deviations, just like we did in 3, and I'm going to give you another example how that works. We call it a standard normal curve. Let me just demonstrate this, guys. Okay, let's take this curve. The mean is, let's make it 20, and the standard deviation is 5. Okay, I'm gonna do 3 tick marks to the end and another 3 tick marks from the other side and add 5 every time. 25, 30, 35. And 15, subtract 5, 10, subtract 5 is 5. This is the normal curve, guys. Now, if I take this value, guys, and I tell you how many standard deviation is this value above the mean, what do you answer?
1.
1. Okay, I'm going to change this to 1. If I ask you how many standard deviation is 30 above the mean, the difference is 10, right? Which is 2 5s, which is a 2. You see what's happening, guys? That's a 3. What about 15? How many standard deviation is 15 below the mean?
Negative.
But below you have to use what? Negative, -2, -3. What about the mean itself? How many standard deviation is 20 away from 20?
0.
0.
Okay.
And that is what we call, guys, the normal standard curve. So instead of using the actual values, you count by how many standard deviation. What you learned, guys, in chapter 2, that what we did here are called the z-scores. So this is by z-scores. Z-score of 1 means 1 standard deviation above the mean. Z-score of 2, 2 standard deviation, etc. So I'll change the label of the axis and call it Z here. And this is what we mean by the standard normal curve, guys. You see the Z here instead of the X. and you see the X here. When you put actual value, it's an X. When you put Z-score, it's a Z. Still same conditions. The area under the curve is 1, symmetric, etc. All the properties that we discussed earlier. All right. Now, this is the formula for the Z-score. It's the value minus the mean divided by the standard deviation. I thought to remind you of this and put it there. That is important. All right. And this is how you change from, this is the example I just did. So this is how you change from a normal curve to a standard normal curve. They're exactly the same, guys, but you label the x-axis differently. Here you label it as X, here you label it as Z. All right. We're gonna do this exercise now. Technology, it's gonna come into play along with tables. There are tables that we will use in this chapter to find values. However, guys, I'm gonna demonstrate the use of tables, but I'm gonna be okay if you decide to use the calculator throughout. I will provide you with links to tables on tests if you like to use them, but I'm gonna demonstrate the use of the calculator as well. If you prefer to use the calculator throughout, that's gonna be an option for you, because I believe people don't carry tables with them, you know, in the work field. And if they need, you know, to refer to it, they have it handy, you know, they do carry technology, smartphones, etc. And I'm gonna make sure that this is the case with you. So let me tell you what this question is, exercise 2. So please pay attention to it. I'm gonna sketch it and show you what we're trying to do here. This is the normal curve. Remember, the total area under the curve is 100%, 1. This is 0. Now you ask why I'm doing Z, because he's asking me for Z. So that's Z. That's 1, 2, and 3. That's -1, -2, and then -3. Oh, sorry, 1, 2, 3. Okay, what does he want? He wants the area to the left of Z equals 1.15. So would you guys agree with me if I tell you 1.15 is somewhere here? And he wants the area to the left. So this is 1.15. Let me write it down. And this is the middle right here. Okay, he wants this area. All right, guys. Any guesses? What do you think this area is? Just give me some estimates. I'm not sure. You're not going to arrive at the correct estimate, but what do you think the answer is? The answer must be between 0 and 1, guys, and area is a probability. So area, you know, the entire area under the curve is 100%. It's 1. So definitely don't go below 0 and don't go above 1. Never, ever. What do you think the answer is? Let's make some guesses. 0.7. Okay, I have one student say 0.7. Do you guys agree with me that it is more than 50% first? It's obvious. If this was a multiple choice and all answers are below 50%, choose the one that is above 50%. Why? Because look, from 0 downward is 50%. So, and there is a little bit more. So definitely it's going to be more than 50%. Any other guesses? What do you think the answer is? Okay, I have one student who guessed 0.7. Let me show you how to find the answer using a table, and then I'll show you how to use the calculator in 1 second. So just give me 1 second to get the table. All right, 1.15. He wants the area to the left of Z equals 1.15. You take the whole number 1 and the 10th digit 0.1 and look it up right here, which is right here, guys, you can see. Then now we need the 100th digit in 1.15, which is the 0.05. The 0.05, guys, is right here. And then from the horizontal arrow, you run a line, and the vertical arrow, you drop a line, and you see where the two meets. Do you guys agree with me that they meet at 0.8749? And that is the answer. So it's right here, guys. 0.87, oh, sorry, 8749. 8749. This table is designed to give you the areas to the left. So anytime you are asked to find the area to the left of a z-score, that is how you do it. You just go to the table, pick up the first digits from the first column, pick up the third digit from the first row, and then see where the two overlap. That will give you the answer, which is 8.8749. I'll go back to my handout and put the answer there. Next question. Find the area to the right of z equals 1.23. Let me sketch it, guys, and then I'm going to ask for your help here. Okay. This is 0 always. This is z. 1.23, let's put it somewhere here. And you guys agree with me, to the right of it, I have to shade to the right. Okay. Any ideas? Let me put the table now. So remember, we need the area to the right of z equals 1.23. I think you agree with me, that, guys, that the answer must be less than 50%, because it's not even 50%. You see, there's a blanks here up to the middle. But let me go back to the table, project it, and ask you, how do you think we do that? Do I look up the 1.23 and find the answer? If you do that, this is 1.2. And then the 3, guys, is right here.
You subtract that from 1.
Ah, very good. Very good. You guys remember that the table only gives you areas to the left. Look at the figure right here in the table. It's designed to give you areas to the left, not to the right. So as you said, when I asked you to find the area to the right, you will find the area to the left and then subtract the answer from 1. Very good. That's exactly what it is. The area to the left is, as we says, 0.8907. So let me write it down. So that's why I said area to the left of Z1 is 0.8907, and your answer will be 1 minus 0.8907. Exactly. So there will be 0.1093. 10%. It's not big, and that is correct. Yeah, it shouldn't be that big of an area. Okay, let's do some more. To the next slide.
Can you show us how to do it on a calculator?
Oh yeah, definitely. It's coming. Because once you start doing it on the calculator, guys, you're gonna quit using the tables probably. All right. This is how I showed you some screenshot of the calculator, guys. Find the area under the standard normal curve to the left of z equal negative 0.99. Oh, negative now. Okay. Well, let's show you this. That this table is called table 4. It has a negative portion of it. So we need to the left of negative 0.99. See the negative values now? So this table is in 2 pages, guys. 1 page for positive values and 1 page for negative values. Negative 0.99. So we need negative 0.9 first, which is right here. Watch carefully, guys. And then the other 9, oh, it's already right there. So it's nice. 0.1611. Let me write it down. Oh, I've already done it here. It's 1.1611 using table force. Let me do a couple more, and then I know I'll go to the calculator. All right. Find the area to the left of z equals negative 0.47. Now I need your help, guys. You're gonna tell me. I'm gonna project it. Remember, it's z equal negative 0.47. Here you go. Oh, I need to move it up so you can see the whole thing. Okay, guys. Negative 0.47.
Is it 0.3192?
Okay, let's see. Negative 0.4 right here. 7 is right here. And where the two meet, what did you say?
The 0.3192.
Exactly. It is 0.3192. Any question, guys? Do you find it difficult to use? It's not difficult. If you remember, if he asks you area to the left, you use the table as is. Area to the right, you use the table, but subtract whatever you get from the table from 1. So it is 3192. Here's how you write it. 0.3192. Okay. When he asks you the area to the left of negative 0.47, that means area for any value is less than negative 0.47. So you write it as less than. Remember, when you go to the left, numbers become smaller. And when you walk to the right on the number line, numbers become larger. So that's what it means. So an area to the left of z equal negative 0.47, guys, it means the probability of z less than negative 0.47. Okay, now I want you to find the area to the right of z equals 1.28. Okay, let me project the positive part of the table and then ask you to help me. So remember, it's the area to the right of z equals 1.28. So what do you do first, guys? I'm waiting.
We look at the 1.2.
1.2 and then 8. Okay, so which is going to be this and that. And where do they meet, guys? They meet at 0.8997, but that's not the answer. What do I do with this answer?
Minus
Subtract
1.
it from 1. So what did we forgot? Well, it was 8997. So z greater than 1.28. It's 1 minus z less than 1.28, and which is 1 minus 0.8997. And then you can do the math. One minus 0.8997 give you about 10%. All right, guys. Now I'm going to ask you to brainstorm with me on this. This is a negative 1.1. That's a 0. And 1.73, I'm going to put it here. And look what he wants, guys. He wants the area between negative 1.1, z equals negative 1.1 and 1.73. Take a few seconds, guys, to think about it and tell me how can I do this using the table. Okay, look, guys, watch. You can find the area to the left of 1.73. If you find the area to the left of 1.73, it's going to give you everything from here all the way to the tail. But I don't want all of that. I want up to here. So look what you can do. Then you can find the area to the left of negative 1.1. and this is the area that you don't want. So you get the area to the left of 1.73, you get the area to the left of negative 1.1, and subtract 2 areas, and that should give you what you want. So always, when you do area in between, you do one area to the left, another area to the left, and then subtract the 2 answers. So it's going to be a probability of z between negative 1.1 and z between 1.73, and it's going to be area to the left of z equal 1.73 minus area to the left of z equals negative 1.1. Let me project the table and you guys can tell me how to do that. So we're going to do 1.73 first. So you got to be familiar with the table in order to use it. For 1.73, this is 1.7, guys. And this is the 3 I got, 0.9582. Minus the other area. Let me just project that. Negative 1.1. There is no hundredths digit, so just make it 0. Negative 1.10, guys. All right. And you can see this is a negative 1.1, and this is the 0 toward the end. So it's going to be 0.1357. Let me just subtract the 2 answers to get what you're looking for. So the answers are 0.9582 minus 0.1357, and your answer is 0.8225. Okay, now you're curious to see how we can do this using technology without using the calculator. I'm gonna use the remaining time. Let me see how much time we still have. Okay, I'm gonna use the remaining time to explain to you how to do this using technology. And again, guys, you in the homework online, a table is gonna pop up every time when you do an exercise. You're gonna have a link to the table. If you don't wanna use the table, that's fine with me. Have your calculator handy to do the work, okay? So please pay attention and see how the calculator is used here. Okay, let me just do it right here. I'm gonna do ABC, guys, using technology. So using TI 84. Okay. For part A, how do you find the probability to the left of z equals z less than negative 0.47? Let me sketch this one right here, guys, just so you can see what we're finding. This is the 0, this is negative 0.47, and we want to find this area. You agree with me, it's less than 50%, and we got 3192. So let's go to the calculator. You ready? And you know what, guys? I'm gonna grab the other calculator, so I'll show you how both calculators work. If you have this or the newer one, so I can show you both. Just give me a second to grab the other calculator. Go to second, variable, second, variables, normal CDF. It's number 2, guys. Normal CDF. And I'll go to normal CDF, enter, and then enter. Okay. You just need to fill in the blanks and you're done, but you need to understand how to fill in the blanks. As you can see, in the TI-84 plus C, it's asking me for a lower bound, upper bound, mean, and standard deviation. This is what you should enter on the screen. Lower bound, upper bound, mean, standard deviation. Let me tell you what the lower should be. Watch. Let me go back to the graph. The lower bound, this is the area that you want. The lower bound is, what is the bound? What's the limit from the left side? As you can see, the tail extends but never touches the x-axis. So it keeps going, you know, just this way to infinity, all the way forever, indefinitely. So what do you think the lower bound, you know, just for the curve is gonna be when you do probability of z less than a number? There is no lower bound, it doesn't stop. So this is what I suggest to use. Use negative a million or negative a trillion. Just use a very large number, but with the negative signs when you do a less than. Look what the calculator by default has here. It has -1 E99. It means -1 with 99 zeros. So, well, you don't need to do this. You can use the negative a million, that should do it. Your upper bound, guys, is just gonna be the end of the curve from the other side. It does have an end, which is -0.47. Okay, so this is the lower bound and this is the upper bound. For example, if you look at this graph, the lower bound will be a negative a million, the upper bound will be -0.99. That's what the lower and the upper bound are. So let's do it here and show you how we're gonna get the exact same answer that we got from the table, guys. So I'm gonna put negative a million in here. Let me do this calculator first. You can put as many zeros as you want, guys. The upper is -0.47. Since we're using Z, the mean is 0 and the standard deviation is 1. You don't touch this one. And now let me go here. Negative a million, comma, negative 0.47, comma, 0, comma, 1. Press enter and press paste. And here you go, 3192, 3192 in both answers if you round to 4 decimal places.
So will the upper always be the number you're trying to find?
If you do less than, yes.
Okay.
If it is less than, it will be that number, the second number. It will always be the second number, definitely. You're gonna see there are 3 scenarios: less than, greater than, in between. That's it. Just learn how to work with each scenario and you mimic this in any exercise. So anytime you guys, you do a less than, you always start with a negative a million or trillion. Just add as many zeros as you want. So let me write this down, what we did on the calculator. It's normal CDF. So this is the only function for probability, guys. You put negative a million, you put negative 0.47, you put 0, you put 1, and we got the same exact answer, 3192. Actually, it's a better answer than the table because it's not rounded. Okay, let's go to B now. Probability of Z greater than 1.28. Okay, let me sketch it. You don't have to sketch it every time, guys, but I'm gonna sketch it, guys, so you see what we're trying to do here. Okay, this is 1.28 here. And we need the area to the right. Okay, what's the lower bound going to be for this question? Any suggestions? Lower bound.
1.28.
Yes, 1.28, because we're starting at 1.28, so it's going to be 1.28. That is correct. And then for the tail, the sky is the limit. It's a million, not negative a million, guys, because it's from the right. So when you do greater than, you start, you know, just with that bound that he gives you, 1.28, a million, then 0, then 1. Let's do it. So if I grab the calculator, watch, guys. You go second and distribute. You go to normal CDF and you put 1.28. So if you ask me, do I always start with 1.28 if it is a greater than with that number? The answer is yes. Upper, then 0.1. Watch. And the nice thing about using calculator, guys, you don't have to do 1 minus. You just do 1 minus because you're using the table that does areas to the left. Here, it does it automatically. You're just going to get your final answer here, which is 0.1003 if you round it to 4 decimal places. So it will be normal CDF. It's normal cumulative density function. And then you put 1.28 million. You can put 1,000, it will work here. 0.1, which is 0.1003. Actually, guys, for C, I never had any student does this wrong. I know it's confusing here confusing between a million and negative million, but for your information, students never got confused when it comes to in between. Negative 1.1 and 1.73. Can you guys tell what I'm gonna do here? It's normal CDF, and then what? What's the lower and what's the upper?
Would you do the negative 1 point?
Yes, exactly, as simple as that. The smaller number is the lower and the upper number is the upper bound, the larger number. So it will be negative 1.1, comma, 1.73, comma, 0, comma, 1. Okay, let's do it. Normal CDF, second in variables. Number 2, guys, not the first one. Negative 1.1, enter. 1.73 should match with what we did using the table. 0.1, don't change that one when you're working with Z. And it's 0.8225. There you go. Look, guys, a match. Perfect match. If you ask me why we still use table and why we use tables before, because the technology at that time was not so sophisticated. Now, with the programs that they use to generate the tables are already built in the calculator, and that's why the calculator can do the job in no time. Any questions, guys, about the use of the calculator? Okay, I got 5 more minutes. Let me just do this question and then we'll wrap this up. I'm going to show you how powerful technology is. If a random variable x is normally distributed, you can find the probability that x will fall in a given interval by calculating the area under the normal curve. So here, guys, I want you to find not the probability of z. There is no z here. It says x, as you can see. Less than 600 using the calculator. Normal CDF. Let's decide on what we're going to put there, and then I'll run the calculator. What's the lower bound here? Okay. What did we agree for less than? The sky is the limit, but from the left. So what do you guys put?
Negative 1 million.
Negative 1 million. What's the upper bound? How far does this curve extend to the right? Where does it stop? At what? 600. Okay. What else? I need the mean and the standard deviation. Do I put 0.1 or that would be wrong here? Do you guys see what the mean and the standard deviation are in this exercise? What did he say the mean is? 500. The standard deviation is 100. You only use 0 and 1 when the question is about z. Look, guys. Z it's 0.1. When it is X, it's the raw data. You just use whatever the mean and the standard deviation. And here is what you put here. You put 500 and you put 100. And look how simple it is, guys, to do it. All of your word problems are gonna turn out to be just like the one I'm doing right now, and the simple calculation using the calculator. Normal CDF, watch. Negative 1 million. I put as many zeros as I want. 600. 0, which is 500 here. 100. Okay, I got 0.8413. All right. So tomorrow, guys, we will continue. Check your email for this handout. You're gonna have the blank handouts. I will scan the chapter 4 handouts and email it to you in addition to the videos that are being available. But please print this handout. We still have a few problems to do together. I'm gonna have you work a little bit more and be active in the class. We're doing some more exercises so you can grasp, this chapter very, very well. Okay, that ends the lesson, guys.
When we do the assignment, can we just scan it to you?
No, I'm going to show you an easy way to send it. It's going to be using the format you submitted chapter 1 assignment.
Okay.